Hey there, math fans. Welcome back to another video over 1.5. I just titled this Even More Solving Absolute Value Inequalities. These are all examples where you have the same thing on one side in the absolute value bars and the same thing on the other side without the absolute value bars. And they're all going to give you different answers, and it all depends on the inequality sign and whether or not it's an and problem or an or problem. Okay, so this is going to basically be a lesson on the importance of recognizing something as an or problem or an and problem. All right, so let's dive into the first example here. I have the absolute value of 3x plus 9 is less than the non-absolute value of 3x plus 9. So it's like a linear equation. So before I do any math, let's first establish if this is an and problem or an or problem. The absolute value is on the less than side, so that makes this a less than problem. In other words, an and problem. And so knowing that it's an and problem means that the overlap is going to be important to my final answer here. And so before I do any math, if I were to sketch a graph of the absolute value side, it'd make a V, right? And then if I were to sketch a graph of the linear side of the same values, it's actually going to make the same graph on the positive side, but a linear function can go negative, and an absolute value function can always go positive. So it's like, you know how the range of an absolute value is y is greater than or equal to 0? So imagine this point being where it equals 0. And then once it goes below 0, the linear side will go negative, but the absolute value side will end up going positive. So that's really important to note, because if we're talking about absolute value of 3x plus 9 is less than the linear side of 3x plus 9, well, that's never going to be the case. For starters, they can always equal each other as long as we're outputting positive values, and then they kind of diverge once it makes 0, right? So once it starts becoming negative, the linear side stays negative, and the absolute value side ends up going positive. So this is impossible. So the final answer is going to be no solution. If you recognize that from the beginning, you can be like, hey, this is no solution because of all of what I just said. If you didn't know that, will the answer show up mathematically? And the answer to that is yes, and I'll show you why right now. So for starters, let's solve this. Just drop the absolute value bars and solve it. So you have 3x plus 9 is less than 3x plus 9. You can never be less than yourself. So this is a false statement. And if you didn't pick up on that, this is a false statement. Well, then if you minus 3x from one side, you would get nothing, right? 3x minus 3x is 0. And then if you minus 9 to the other side, you'd also get nothing. So you'd be getting something that says 0 is less than 0. That's also a false statement. So however you want to think about it, the first answer is false. And so whenever you get a false statement, you got to think to yourself, does that mean the answer is no solution? And the answer to that question is possibly. If it's an and problem and you get a no solution, then yes, it will be no solution for sure. Because if you were to solve this a second time around, you would flip the signs on the non-absolute value side. So I wrote negative 3x minus 9 here. And then you would change this inequality sign from a less than to a greater than. And so we're going to get our x's to one side. So I can add 3x to the left-hand side, and I'd get 6x. And then I can minus 9 to the right-hand side. And so that's going to say 6x is greater than negative 9 minus 9 is negative 18. I can divide both sides by 6, and I'd get x is greater than negative 3. And so you'd think, well, that's great. So why isn't that the answer? And so the reason why it's not the answer is because when something is an and problem, that means both scenarios must be true. So how is it possible that you can be greater than -3 and be no solution? That doesn't make sense. So the no solution kind of wins out if you think of it like that. Um, so the answer is, in fact, no solution. And it's pretty much only ever going to be no solution when it is an and problem. Now, if this was an or problem, the answer would not be no solution because you have the option of being no solution or something else. So we'll get to that when we get there. For my second example, I have 3x minus 5 is greater than or equal to the absolute value of 3x minus 5. So let's think about this. Is this an or problem or an and problem? It's eating the 3x minus 5 side, so that means that side's greater than the absolute value side. So the absolute value side is less than the other side, making this another and problem because the absolute value is less than the other side, if you want to think about it like that. Can the linear side ever be greater than the absolute value side? So I'm going to go back to this, sketch that I drew earlier. This is what's going on. You have the absolute value and the linear overlapping. They overlap whenever it's positive. So it's actually impossible for the linear to be greater than the absolute value side. However, it is completely possible for it to equal the absolute value side because they overlap whenever they're both making positive values. And then they don't overlap once the linear makes negative and the absolute value makes positive. Okay, so this is going to have an answer because they can equal each other. So the first thing I'm going to do is drop the absolute value bars and solve it without changing anything else. And so this, you get a true statement. Is 3x minus 5 greater than or equal to 3x minus 5? Well, it's not greater than itself, but it can equal itself. So once again, if you were to like minus 3x from one side, you'd cancel it out on both sides. And then if you were to add 5 to both sides, you'd cancel it out. And then you'd end up with this statement that says 0 is greater than or equal to 0, which again is a true statement. So anytime I get a true statement, like everything's true or whatever, then you got to think, does that mean it's an all real numbers kind of scenario? And the short answer is because it's an and scenario, it can't be all real numbers and something else, because and's all about the overlap. So it's not going to be all real numbers. It will be something else, and I'll show you why for the second time that we solve this. So the second time I solve it, I'm going to want to flip the signs on the non-absolute value side. So this becomes negative 3x plus 5, and then change the inequality sign. All right, so let's get our x's to one side so I can add 3x to the right-hand side. And that means I will have to add 5 to the left-hand side. And so 5 plus 5 is 10. 10 is less than or equal to 3x plus 3x is 6x. And so divide both sides by 6. That's going to make a fraction that can simplify. 10 over 6 will make 5 over 3. So you get 5 over 3 is less than or equal to x. I like to rewrite these with the x coming first. So that would mean it's x is greater than or equal to 5 over 3. I didn't change anything. If you notice, it is pointing to the 5 over 3 and eating the x this way. So it is pointing to the 5 over 3 and eating the x that way. So I get x is greater than or equal to 5 over 3, and then I get maybe all real numbers. And so I think, well, this is an and problem. So if I were to draw a number line, all real numbers means anything positive or negative, right? But the other answer says you have a solid dot here at 5 over 3, and then it's going to the right. And what we've learned from previous lessons is that and problems are all about the overlap. So they're only true when they are both true. And so they are both true once they start overlapping. And so that means the final answer to this problem is x is greater than or equal to 5 over 3. So for my next example, I have 2x plus 14 is less than the absolute value of 2x plus 14. So that means it's eating the absolute value side. So the absolute value side is greater than the other side, making this an OR problem. So your first statement, 2x plus 14, is that less than 2x plus 14? No, that's not true. Again, everything would cancel out and it would make a statement that says 0 is less than 0, which is not true. So then you ask yourself, does that mean it's no solution? Well, in the on the first example, it was no solution because it was an and problem. It can't be no solution and something else, but it can be no solution or something else. So if you have the option of actually having an answer, then you're gonna have an answer, simply put. So we are going to solve it the second time around. We're gonna change the signs on our linear side. And so I have negative 2x minus 14 now. And then I'm going to flip the inequality sign from a less than and turn it into a greater than, and then just bring down 2x plus 14. So we can get our x's on one side by plussing 2x to the right-hand side, and then that means I will have to minus 14 to the left-hand side, and so negative 14 minus 14 is negative 28. That is going to be greater than 2x plus 2x is 4x, so I can divide both sides by 4x, and I'll get negative 7 is greater than x, or I like to rewrite it from the perspective of x, which is x is less than negative 7. So if you have an answer, again, and you have one of them is no solution and you have an OR problem, then the answer is the other solution. When given the choice, if only one of them has to be true, because it's an OR problem, the answer is x is less than negative 7 or no solution, well then the only thing that makes sense to say is x is less than negative 7 for your final answer. Okay, so for my final example, we have 6x plus 12 and the absolute value bars is greater than or equal to 6x plus 12. So the absolute value is being eaten by the inequality sign, so it is on the greater side, making this an OR problem. So now if we were to drop the absolute value bars and solve without changing any signs, you get a true statement because 6x plus 12 is greater than or equal to 6x plus 12. It's obviously not greater than it, but it is equal to it. So this is a true statement. So if you get just kind of a true statement, then you have to think, does that mean the answer is all real numbers? And so if you have an OR problem and one of your answers is all real numbers, um, the answer will be all real numbers because since or the overlap doesn't matter, you can have all real numbers or something else. And so it's just like, well, you can choose one or the other or both. So therefore, you can choose all real numbers for your answer if you want to think about it like that. But if that doesn't really make sense for you, then I'll solve it a second time around and we'll see how that goes. So I'm going to keep the absolute value side the same. I'm going to flip my inequality sign. Then I'm going to change the linear side, change all the signs. So 6x becomes negative 6x and plus 12 becomes minus 12. So let's get our x's on one side so I can add my 6x to the left-hand side, and then that'll cancel my x's, and then I can minus my 12 to the right-hand side, and that'll cancel my constants. So let's see here, 6x plus 6x is 12x. That's going to be less than or equal to negative 12 minus 12 is negative 24. And so we're going to divide by 12 here, and we're going to get x is less than or equal to negative 2. So this is an OR problem. Your answers were all real numbers, and x is less than or equal to negative 2. So if you were to draw a number line, and you had negative 2 here, you'd put a solid dot because of the or equals to option, and then you'd shade to the left. But if it's all real numbers, you can shade to the left or you can shade to the right because you can literally choose any number. And since overlap does not matter for OR problems, then all numbers are true, okay? And then if that still doesn't make sense, then let's just draw this graph that I mentioned earlier. And so you have your v for your absolute value side and your linear side. I did not draw this very well. But the key here is that they overlap when they're both positive, right? Because if you plug in like a positive number and absolute value, it's going to make a positive output. So same thing for like a linear equation. Um, and so when this says the absolute value is greater than or equal to, it is equal to it when they're both positive. And then once linear goes negative, absolute value turns positive, and so absolute value will be greater than the linear side. So absolute value will always be greater than or equal to a linear equation of the same exact thing. So there's another way of thinking about it. Because these have the same exact terms, then the absolute value side will always be equal to it or greater than it. Okay. So I hope that explanation made sense. With that being said, that's going to draw these notes to a close. So thank you for watching and goodbye.